Welcome to this Ansys Auto Series video. In this video, we will focus on how to use Ansys SpaceClaim to prepare the geometry of a Formula FSAE car for aerodynamic analysis using Ansys Fluent. You will learn how to create an enclosure around the car, how to set up bodies of influence to drive the meshing phase, and finally, how to create name selections. Ready? Let's go! This is the solid model of an FSAE car that we will be using in this example. It is about 3 meters long, 1.2 meters high, and 1.4 meters wide. In the model, we can identify the front wing, the rear wing, the chassis with a pilot, front and rear wheels, suspensions, and brakes. If you look close to the tires, you can see that we have added a fillet in the region where the tire will touch the ground. This is a practical trick to avoid sharp angles between the tire and the ground that will lead to bad quality cells during the meshing phase. First, we will create an enclosure. This is the volume we will analyze to study how the air interacts with the car and what forces are generated. The analysis will look as if we were testing the car inside a wind tunnel. As you can see, the car is symmetric. For our analysis, we will only use half of the enclosure to reduce the mesh size and the computational cost of the simulation. Next, we will generate bodies of influence, or BOIs, that will help us control the mesh size and refine only the regions of interest during the meshing phase. This is a useful step to have accurate results in the vicinity of the car. Lastly, we will create name selections that will be fundamental for quickly specifying local meshing controls during the meshing phase and defining the proper boundary conditions for the simulation. Start a workbench session. Bring the geometry module onto the project schematic window and link a Fluent meshing module. Right-click on the Geometry tab and import the car model. Then, open the model in Ansys SpaceClaim. Hold Ctrl and select the X and Z axis, and then click on the Plane tool to create the bottom plane. Repeat the same for the X and Y axis to create a middle plane. These planes will be used later, so let's hide them for now. Our geometry is relatively clean, but if you are using a different geometry, you may find the tools under the Repair tab useful. These tools can be used to fix features of the model that are important in creating a high-quality mesh. Create an enclosure around the car by clicking Enclosure and then box selecting all the components. Have the enclosure length behind the car about 3 times the length of the car, in our case 9000 millimeters. To capture the wake and place the outlet away from the region of interest. Have the enclosure width and height to 1 car length, in our case 3000 millimeters. Click the Complete button. Make sure to conduct a domain study by varying its dimensions and understanding how it affects the flow. In the structure tree, toggle on the middle plane and hide the enclosure. Double-click on the Z-axis on the bottom right corner to align the view. Select the plane and activate the Rectangle tool. Sketch a rough rectangle around the car. Switch to the 3D mode and select the Pull tool. Now, click on the Pull in both directions option for the Pull tool and pull the rectangle by 1500 mm in both directions. This is a body of influence that will be renamed BOI1 for simplicity. Copy and paste BOI1 using Ctrl+C and then Ctrl+V and rename this to BOI2. Hide BOI1 and select only these 5 faces. We will now pull these faces of BOI2 in all the directions by typing 500 mm and then hitting enter. Unhide the enclosure. Hold Ctrl and scroll the middle mouse wheel to choose the BOI2 back face. Click on the face and pull it up to the end of the enclosure. Triple-click the bodies of influence and change the transparency for both. Hide everything except the wheels. Triple-click to select the front one and create an origin at the center of the wheel. Then, hold Ctrl and select both the axis system to find the location of the center of the wheel. Note down the X, Y, and Z coordinates. You will need them later to define the boundary conditions. Repeat the same process for the back wheel and make a note of these coordinates as well. Next, delete the origin in the wheels as it is not needed anymore. Unhide the enclosure and the planes. Using the Split Body tool, cut the model with the planes we have created before. Cut the body as shown. Hold Ctrl when choosing the cutting planes and then select the part to delete, as shown. As the cut is symmetrical, for the simulation we will only use half of the enclosure, saving computational costs and time. The bodies of influence don't necessarily need to be cut, as the excess geometry will not be considered during meshing. Select the front face of the enclosure and then go to Groups to create name selections. Name this as Inlet. Create the name selections for the remaining external boundaries by repeating these steps. The name selections for the external boundaries are shown here: Inlet, Outlet, Symmetry, Ground, and Tunnel walls. Select all the faces and hide them. Triple-click to select the body and create a name selection called BOI Far Field. Repeat the same process for BOI Near Field. When selecting geometry, holding the left mouse button and dragging from different corners has different functions. Dragging from the bottom right to the top left will select all the faces as it touches. Dragging from the top left to the bottom right will select only those that are within the selection box. Call this rear wing and repeat the same process for all the components of the car. We have the rear wing, the wheels radi, there are the fillets we discussed before, the rods, the rear wheel and front wheel, similarly rear brakes and front brakes, the front wing, and lastly the chassis. Show all the components and suppress the car for physics. This ensures the car model does not come into the Fluent mesh. And save the geometry. So, let's summarize. The geometry preparation for an external aerodynamics analysis requires the creation of an enclosure around the model, which will be the volume of analysis. Bodies of influence can help simplify the meshing process and refine specific region of the enclosure, where we want more accurate results. For example, around the car body and in the car's wake. Another very good practice is to set name selections. As you will see, this step simplifies both meshing and simulation setup processes. Keep these tips in your mind when preparing the geometry for a fluid dynamics simulation. If you found this video helpful, please like, share and subscribe. To find more information about Ansys SpaceClaim tools or other topics, check our channel for more how-to videos and visit ansys.com/courses today.